You are in the meeting now.
Recording in progress.
Hey, good morning, everybody. How are y'all doing? Thumbs up? Awesome. All right. Well, I don't have any real announcements for us, so um, let's just begin by opening up the floor. Today we're talking about assignment 17, polynomial and rational inequalities. Um, I hope that you have found this to be a rather straightforward assignment. Um, but if you have any questions, if there's any homework problems that you want to take a look at, um, anything that you want clarified, this is a time to address those questions. So like I said, I don't have any announcements on my plate, so as I like to say, the floor is yours. Um, what can we look at together in regards to assignment 17, or if there's anything lingering from assignment 16?
Mr. Clopton,
I'm sorry, could you speak up just a little bit?
it's Sudan. Are things finally working?
Did you say problem number 13?
It's Sudan, and our system is finally working.
Oh, your system is finally working. Yay!
But I
Um,
have a on assignment 16.
say that one more time.
I have a question on assignment 16.
Assignment 16. Alright, so what is your question on assignment 16?
Can you explain number 8?
Yes. That would be week 9. Problem 16, number 8. Okay. You did say problem 8, correct?
Yes.
Okay. Alright. We're taking a look at assignment 16, problem number 8, and we are given f of x is equal to 1 over x, and we are told to graph f of x is equal to 8 over x, correct? 8 over x. Okay. So, real quickly, I just want to take a quick reminder of what does the graph of 1 over x look like. And a graph of 1 over x looks something like this. Where we have a vertical asymptote at x equals 0, we have a horizontal asymptote at y equal to 0, and the graph behaves like this, and specifically speaking, if you do, let's say, f at 1, that's 1 over 1, which is equal to 1. So this point right here, if you plug in 1, your output is 1, you get 1, 1. And if you do f at negative 1, that's negative 1 over 1, which is a negative 1. So you get this point right here, which is a negative 1, negative 1. Alright, so, and then as your x's get larger, your graph starts converging towards the horizontal asymptote y equal to 0, and as your x values go between 1 and 0, your graph just starts shooting up to either infinity or to negative infinity if your x is between negative 1 and 0. Alright, so that is the graph of f of x. Now, let's take a moment to think about this function f of x is equal to 8 over x. And something that you can do here is you can rewrite this as 8 times 1 over x. So we know what this function 1 over x is doing. It's doing this. But if you're multiplying it by 8, essentially this means that you're going to be multiply the output values, and when I say output values, I mean the y's of 1 over x by 8. So for f of x equal to 8 over x, that would mean if you do, let's say, f at 1, that's going to be 8 over 1, which is going to be 8. So that is basically taking the 1 that we had up here and multiplying it by 8. And if you have f at negative 1, it's going to be 8 over a negative 1. Sorry, I made a boo-boo up here. Back over here, I should have had the negative 1 on the bottom. 1 over negative 1. There we go. But going back over here, that becomes a negative 8. So basically what's going to happen is your y values are all going to get multiplied by 8. So when we look at this graph, so let's just pretend like this is 1, 1 and negative 1, 1. So you got 1, I'll zoom in, you get 1, 1, negative 1, negative 1. So if we are graphing the function 1 over x, our graph would start here at 1, 1 and do like this. But since we're graphing 8 over x, we're going to multiply all of our y values through by 8. So when we plug in 1, we actually get out 8. So on my graph, I'm going to put 8 right up here. So now my graph looks like this. You plug in 1, you get out 8. If you plug in -1, you're going to get out -8. So we'll put -8 right here. Now, you're still going to have a vertical asymptote at 0. You're still going to have a horizontal asymptote at 0. Let's keep playing around with this a little bit. If you do f at 8, that becomes 8 over 8, which is equal to 1, and f at -8 is going to be 8 over -8, which is going to be a -1. So when you plug in, let's go over here again to our graph. If you plug in 8, your output value is 1. If you plug in -8, your output value is a -1. And so what's going to happen is your graph is going to behave essentially the same way. And perhaps it would be better if I used Desmos. But what's essentially happening is the difference between these two graphs, even though they look the same, their output values are different. And you can almost get this graph of f of x equals 8 over x by taking this graph right here of 1 over x and you pull the graph this way. If you pull the graph out a little bit, you're going to get this graph right here. It's just kind of like pulling it out sideways. And that's the difference. In fact, if you just don't mind, let me just take a quick moment. If we go to Desmos, I like doing things in Desmos. They make so much better graphs. 1 divided by x. So there's your graph of 1 divided by x. But if we do 8 divided by x, there, can you see it? It's basically, you're just taking 1 over x and you're pulling it out this way. And that's the difference. So if I were to graph these on the same coordinate plane, if I were to put f of x on and 8 over x on the same coordinate plane, this is what I would do. So in blue, blue is 1 over x. And if I was going to graph 8 over x on the same coordinate plane, I would just do something like, let's do it a little bit better. I would do something like that. That would be 8 over x. I meant to say 1 over x instead of 1 over 8. There we go. All right. Does that explain the difference? Does that answer your question?
Yes, thank you.
You're welcome. All right. What else can we look at? Anything from assignment 17? I'm sorry. Let me ask a question. Have y'all started assignment 17? Have y'all finished assignment 17? Where are y'all at?
We're just starting with assignment 17.
Okay, anybody else?
We've started it.
Can we
Okay.
do number 8?
I'm sorry, what?
Can we do number 8?
On what assignment?
17, please.
Yes. Alright. The nice thing about, at least in my mind, the nice thing about assignment 17 is, well, number one, let me just say this. You can always check your results by graphing the function. If you take the time to graph the given functions, whether they be polynomial functions or rational functions, you can visualize what the result is just by looking at the graph. But the nice thing about this is you don't actually have to graph these functions in order to get the results. In fact, we could have done this lesson way up at the beginning of the semester. It may have not made as much sense back then because the graph is, again, the nice visual representation of the solution, but you could have done this way back at the beginning of the semester, and that's the way we're going to approach this. We're going to approach solving these problems using very basic tools. So let's take a look at problem number 8. Is number 8, is that what you asked? Is that correct? Yes, no? Is that correct, problem number 8?
Yes.
Alright, thank you. Alright, we want to solve 2x squared minus 9x plus 7 is less than or equal to 0. And we'll graph and put the solution in interval notation. So the first thing I'm going to do is I'm going to start off by solving 2x squared minus 9x plus 7 equal to 0. And the reason that we want to do this is we want to find the zeros of our function. Alright, so does this factor? The answer is going to be yes, it does factor. I'm looking at 2 times 7 is 14. What are the factors of 14 that add up to a negative 9? How about a negative 2 and a negative 7? So I need a 2x and an x. And I said I need a negative 2 and a negative 7, so I'll put negative 1 and then negative 7. Double check. 2x times x is my 2x squared. 2x times negative 1 is going to be a negative 2x. Negative 7 times x is going to be a negative 7x. Negative 7x and a negative 2x makes a negative 9x. Then negative 7 times a negative 1 is a positive 7. Alright, so there's the factored form, which then you can set each factor equal to 0. Which then we get add 7 divided by 2, x is equal to 7 halves, and then add 1, x is equal to 1. So these are the zeros of the function. So I'm going to take these and I'm going to put them on a number line. So in order from least to greatest, we have 1. And then we have 7 halves, which is a 3.5. And when I graph this on a number line, I see 1, 2, 3 intervals. And what we want to do is we want to test each interval to find out whether the graph is, or whether the function is positive or negative. So here I begin my testing phase. So let's pick a nice value between 1 and, or negative infinity and 1. How about 0? And I don't have to do a whole lot of work here because if I plug in 0 into my original function, we get 7, which is positive. So I just like to put a little plus sign. This tells me that everything in this interval is positive. Again, I'm pretending like I have no knowledge of the shape of the graph. Even though I know what this looks like, we know it's a parabola that opens up. Let's pretend like we have no knowledge of this. F at 2, that would be a good thing to pick. So, let's see. 2 squared is 2 times 2 is 4. Or 2 squared is 4 times 2 is 8. Then negative 9 times 2 is a negative 18. So 8 minus 18 is a negative 10 plus 3, that's a negative 3, which is negative. So I'll put a minus sign right up there. And then I like to pick easy things that I can work with, like 10. Because if I do 10 squared, that's 100, times 2 is 200. Minus 90 plus 7, you know what, I don't even care what that number is anymore. I know it's positive. Alright, so let's go back to what we want to find. We want to find when the function is less than or equal to 0. That means when it's negative. So we can shade in that interval. Now notice the less than or equal. It's less than or equal to 0. So at 7/2 and 1, it is equal to 0, so we can include those values. I'm going to include those values by indicating a solid circle. So here's my graph number line that represents this inequality. And you know what, if you include your little plus minus plus up here, it doesn't bother me because I know what you're talking about. I've seen the work down here. And you know, also you'll notice that I didn't just say plus minus plus. I went through and did some testing. Now this testing you can do with your calculator, or you can do like I did. I did it in my head, and all I cared about was positive, or whatever your output value is. So now I'm going to put this in interval notation. So we have 1 to 7/2, but because of the solid circle, we want to put brackets. And there is our answer in interval notation. Just to bring things home, if we were to graph this, I'm not going to do an excellent job graphing. Here's 1. Here is 7/2. So we know that when we graph, those are the x-intercepts. We have a y-intercept way up here at 7. If we did a little bit of work, we could find the vertex. So our graph would look something like this. And when is the graph below 0? When is the graph less than or equal to 0? It's less than or equal to 0 in this shaded region from the -1 to the 7/2. So does that make sense?
Yes, sir.
Awesome. What else can we look at?
Mr. Clopton,
Yes.
can you, I'm a little confused on the arrow notation used in assignment 16. Can you just like explain arrow notation?
Could you speak up just a little bit louder? I have my volume all the way up.
Could you explain arrow notation again? It was used in assignment 16.
Oh, so interval notation, is that what you asked?
Arrow notation.
Arrow notation.
Yes.
Okay, yes, all right, I'm with you now. So if you don't mind, let me just create a problem where we deal with arrow notation. I get what you're talking about. So, from assignment 16, let's suppose that we had this function now. In regards to assignment 16, a lot of these questions ask about the as f of x approaches blah blah blah. Make sure that you go ahead and graph this, graph the function before you answer those questions. So let's suppose that we have a problem and we've just gone through and we graphed it. I'm going to call this f of x equals, and I don't know what's going to be yet because I'm just making this up. We'll have a vertical asymptote here. That's going to be x equal to 0. Let's have a vertical asymptote here at x equal to 1. Let's have a horizontal asymptote here at y equal to 1. And let's do the following.
Sorry, we can't see.
Well, that's because I didn't turn the camera on. There we go. Is that better?
Yes, sir.
Alright, so what I'm doing is I'm just creating a graph of some rational function. Alright, so I just made this up. I just made this graph up, okay? Just made it up. And I'm not going to even try to come up with the equation that would represent this graph. I just made this graph up. So let's start asking some questions in regards to the arrow notation. So one of the questions that you would see is this. As x approaches, alright, so stop. This is saying as x is approaching, as x is getting closer to 0. And we're going to do 0 from what the minus sign means, from the left. So as x approaches 0 from the left, what is your function doing? So remember, the function is f of x. Everywhere that you see the blue, that is the function f of x. And we want to know what is it approaching? We're asking for the y value. So as f of x as x approaches 0 from the left, f of x is approaching what? So here we are on the left side of 0, and we are on the graph f of x. So we're going towards 0 from the left. What is the graph doing? It starts going up, 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 and it's going to go up all the way to infinity as it gets closer and closer to 0. So f of x is approaching positive infinity. We can also do as x is approaching 0 with a plus sign, means you're approaching 0 from the right. So you're on the right side of 0 and you're getting closer to 0. What is the function doing? Well, if you're on the other side of 0, so you're on the right side of 0, and you're going to get closer to 0, so as x gets closer and closer to 0, my graph is going up. What's the y value that it's getting close to? It's getting close to infinity. Maybe I should have done this graph a little bit differently. Let me change this up just a little bit. So you can see that as x is approaching 0 from either the left or the right, it's approaching the same y value of infinity. But if you go to the next vertical asymptote here at 1, as x is approaching 1, what does the minus sign mean? From the left, f of x is approaching, so you're on the left side of 1, you're writing the function, so it went down, now it's going up, it's going to go up indefinitely as you get closer to 1, so f of x is approaching infinity. But you can see that as we approach 1 from the right, so now we're on the right side of 1, we're writing the graph. What is the graph doing? It starts going down, 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 down. That is approaching negative infinity as we get closer to 1. Alright, so does that clarify things, or do you have some further questions? Do you want to see another example? How else can I help with explaining this?
That makes sense. I was just confused about the y value.
The y value? So,
Yeah.
one of the things that, okay. So, the idea is whenever we talk about x, as x is approaching something, you're talking about values along the x-axis. You're talking about values that are along the x-axis. Whenever we talk about f of x is the same thing as y, so that's going to be your y values, what's on the y-axis. So f of x, you can always replace f of x with y. So another way to say this is as x is approaching 0, what is the y value of the graph getting close to? So the y value of the graph could be getting close to, it could be going up, so it could be getting close to infinity, or the y value could be going down, and it could be getting close to negative infinity. There's another interesting problem, and I'll do this one last example, and if we need to do more, we can do more. There's this other interesting problem that we can look at as x is approaching, so I'm going to come down here, I'm going to label this point right here as 2, 0. So as x is approaching 2, f of x is approaching what? Now this is an interesting problem because unlike at 1, at x equal to 1, if you're coming in from the left and then from the right, they're going to different values. From the left, you're going up to infinity. From the right, you're going down to infinity. You're converging to different values as you approach 1 from the left or the right. But as you approach 2 from either the left or the right, you can see that they're both approaching the same y value. As you approach 2 from the left, you're getting close to 0. As you approach 2 from the right, you're also getting close to 0. So there's no need for a plus or minus notation here. Because as x is approaching 2, you're getting the same y value that is going to be 0. Alright.
You can't see.
Sorry. Sorry, sometimes I get into that state where I forget about those videos. So, just to explain this again, if you're approaching 2, the x value of 2, either from the left or from the right, you're approaching the same y value, 0. So that's why there's no need for a plus or minus notation here, because if you're approaching 2 from the left or from the right, you're approaching the same value. Alright, so I apologize about not getting that screen up. Alright, is there any other questions that we can look at with assignment 17? I should note that the first first 5 problems, problems 1 through 5, are all really just review problems. So if you're working on assignment 17 and you want to have some questions, I would be looking at problems 6 through 13 if you have any questions.
Can we do number 13?
Number 13. We have 2x plus 1 over an x minus 3 is less than or equal to 3. Alright. The issue that we have here, here's the issue. This is not less than or equal to 0. That's going to be the first problem that we're going to encounter in this problem. The only way to solve this problem without and by leaving it as less than or equal to 3 would be to graph it, and then graph y equal to 3 and see what the graph looks like and see what that graph tells us. We want to be able to do this problem without graphing. So that's a problem. It's not less than or equal to 0. So what we want to do is we want to set this to be less than or equal to 0. And the way we do that is we simply go through and we're going to subtract the 3 on both sides. So all I did is I just moved the 3 over by subtracting. Now, here we have a problem. I have 2 expressions. One of these expressions is a rational expression. One of these is just a constant. What we need to do is we need to bring these 2 together. So we now want 1 term. I have 2 terms. I want 1 term. So we need to put these 2 things together. So this is something that we didn't talk about in this course because this is something that you need to be able to do coming into this course. How do you combine a rational expression with a constant? We need a common denominator, or an LCD, which is going to be the x minus 3. So what we're going to do is we're going to multiply. I know this is a little bit messy. We're going to multiply that negative 3 by, or 3 by the x minus, we're going to multiply negative 3 by x minus 3 over an x minus 3. So you're going to get 2x plus 1 over an x minus 3. Make sure you're distributing that negative with 3. So negative 3 times x is a negative 3x. Negative 3 times a negative 3 is a positive 9 over x minus 3. Now this is less than or equal to 0. So now we can put these two terms together because they have the same denominator. So we have 2x plus 1 minus 3x plus 9 all over x minus 3. It's less than or equal to 0. So now what we can do is we can put our like terms together. So 2x minus 3x, that's going to be a negative x. Plus 1 plus 9, that's going to be a plus 10. X minus 3 is less than or equal to 0. Now, at this point, because we're dealing with a rational function, how do we know that this is rational? Because it's a fractional expression with a variable in our denominator. We want to know what are the x-intercepts and what are the vertical asymptotes. We need to know these two things. So to find the x-intercepts, how do we find x-intercepts? We set p of x, or the numerator, equal to 0. So p of x equal to 0 means you have negative x plus 10 is equal to 0. Which then we have negative x is equal to negative 10, which then means x is equal to 10. So I'm just going to circle this. I'm going to highlight it. That's my x-intercept. We also need to know the vertical asymptote. So to find that vertical asymptote, you set the denominator equal to 0, set q of x equal to 0. So that's going to be x minus 3 is equal to 0, which means that x is equal to a positive 3. So now, what we're going to do is we're going to put this information on a number line. So we'll just take this information, bring it up here. So on a number line, I'm going to place, in order of least to greatest, we got 3 and then 10. I'm going to go ahead and put circles around this. And I'm going to quickly mark that 3 is my vertical asymptote. Now, we want to know, going back to the original function, when was it less than or equal to 3? When we move that 3 over and combine everything, we want to know when is this less than or equal to 0. So what we're going to do is we're going to go through and we're going to test values that are in these intervals. And we're going to test values with this function down here, negative x plus 10 over an x minus 3. We're going to test our values with this function. So if I do f at 0, that's going to end up being a 10 over a negative 3. That's going to be negative. 10 over negative 3 is a negative. So I'm going to put a little minus sign right there. Something between 3 and 10. How about 5? So negative 5 plus 10 is going to be a positive 5. 5 minus 3 is going to be a positive 2. A positive divided by a positive is going to be positive. And then let's do something over here. I like to make my life easy, so 100. Great number. Negative 100 plus 10 is going to be negative. Then 100 minus 3 is positive, so a negative divided by a positive is negative. So we had positive, negative. So when is this function less than 0? Here and here. Now more specifically it said less than or equal to. Now, because this is a vertical asymptote, we cannot plug in values at 3 because at 3 it's undefined. So we can't circle, or we can't make this open circle solid because we cannot include 3 when we evaluate this function. But we can include 10, so I can shade that. So there's the graph that represents my solution set. How do you put this in interval notation? Well, you have two intervals. First interval is from negative infinity to 3, unioned with the second interval, that's from 10 to positive infinity, but we're including 10, so we put a bracket and then a parenthesis around the infinity. And there's our solution set. There is our solution set. Now you can verify this by looking at the graph. In fact, let's look at the graph of the original function. So I'm going to go back to Desmos. The original function was a 2x plus 1 over an x minus 3, and this was set to be we want to know when it was at less than 3. So what I'm going to do is I'm going to graph the line y equal to 3. So, and I'm going to also plot the vertical asymptote. We have a vertical asymptote at x equal to positive 3. Alright, so check this out. This purple line right here represents y equal to 3. In fact, if I do a little bit of setting real quick, 1, 1, let's get rid of those minor grid lines. There you go. We can see this graph. This purple dotted line represents y equal to 3. The green line, the green curves that you see here represent the original function 2x plus 1 over x minus 3. When is this function less than 0? Well, less than 3. Well, it's less than 3 from negative infinity all the way up until you get to x equal to 3. At x equal to 3, you have that vertical asymptote. Then it's above y equal to 3 all the way until, check this out, this point right here. It's above 3, it's above 3, it's above 3, and then as soon as you get to x equal to 10, it's below 3. It's below 3. So this is the graph of the original function, the original inequality. But what we had to do was we had to get that 3 over to the other side, combine our two terms together. We needed a common denominator, and then we solve this inequality. And by solving this inequality to be less than or equal to 0, we now know the answer to this original inequality up here. So I know I did a couple of examples like this, I know at least one. I think I did 2 of these examples in the notes. Does this process make sense? Can you follow the math? Can you follow the math?
Yes, sir.
Okay. Alright. The lady voice is about to tell me that I have 2 minutes remaining. Should have already said that. This week, remainder of this week, we have assignment 18 that we'll talk about on Friday. First of all, I probably should apologize for assignment 18 videos. I ended up making those videos after 10 o'clock, which I should never make videos after 10 because my brain isn't 100% functioning after 10.
Your conference is scheduled to end in 2 minutes.
And I dare not drink any coffee after 10. So I make a few mistakes as I go through the videos. I correct those mistakes, but it's after I make a mistake and then I say, oh, I made a mistake. So I'm probably going to have to redo those videos at some point, but I'm not going to redo them now. So I apologize for the mistakes that I make in assignment 18 notes. But we will be looking at assignment 18 on Friday and plan on having a quiz on Friday as well. So that's all we have for today. As a reminder, if y'all have already submitted your homework for assignment 16 back in week 9, that's fine. I'm going to ask you to resubmit that with week 10 homework, just because when I grade week 10 homework, I'm going to be looking for assignment 16, 17, and 18 notes and homework. Alright, so as always, feel free to email me if you have any questions, and other than that, I will see y'all on Friday. Have a good rest of your day and Thursday. Goodbye.
Is this quiz coming up over assignment 16 and 17?
Yes.
Okay. Thank you.
You're welcome.
Your conference is now over. Goodbye.